All right, on the crossword, I'm going to answer a couple of questions off the crossword, a couple of questions off of the word search, then I'm going to collect it, and then we'll take the vocab test. 13 down says the four parts of coordinate plane. So if I draw a coordinate plane, your x and y axes, what are these four parts called? Quadrants.
I just spelled my name, that's why it didn't fit.
I'm not sure, is there supposed to be an S on it? So
Yes.
would I probably put that on this vocabulary test you got coming up? Probably not.
It's not today?
Yeah, it's today.
Okay, okay.
Next question. I'm just trying to point out if
Will you tell us what it is? Like, is it math? You have to just know it? Is
you
there a
gotta
word
know it,
bank?
gotta write it down.
Like the definition? Are you saying? No. That is.
Come on, keep going. You're not helping yourself by sitting here saying, ooh, it's not helping.
I know some of them, but I don't know the.
10 down. An angle formed by opposite rays is blank. So 10 down. If I draw my ray here, somebody else come up and draw an opposite ray to that.
Can I just make a guess?
I'm guessing. I think like
Connect it, I think. Like, just go off the other side and go the other way.
So we have those two.
forget about that.
Ow!
They're opposite rays. Those two are opposite rays.
What'd you do?
What'd they form? Shh. We're going to start the test right now here in a second if any more disruptions. It's a straight angle. I think we just need the word straight, right?
Yep.
Straight angle. Next question.
Oh. 8.
Two angles with common side but no common interior points are. So let's draw this. That's my first angle. This is what a lot of you need to do. You got, and I've been saying this all year long, you got to be able to draw things. If you're not sure, draw a picture. So we got that angle. Then they tell us the second angle is related to that one how? Has a what? Common side. So I'm going to make that. That could be the common side. Then I got to finish out my angle, right? Maybe something like that. What kind of angles are those two to each other? Adjacent. Do you think I'd put adjacent angles on this test? Is that something that we use just about every day? Something that's real important? No. Because I don't much care about adjacent angles. And I've been telling you that all year long. If I give you those two angles right there, do I want you to tell me that they're adjacent to each other? No, there's two other names that are better names that tell us more. What do I want to know about those two angles? They're supplementary or they're linear pair. All right? That's more important. Do you think those two might be on this test? Yeah, those are much more important than adjacent. What are supplementary angles?
Angles that measure adds two angles that measure adds up to
Greater than 90, less than.
So, supplementary angles, two angles, make sure you write that part in there if that's on here, because if you write something other than, if you just write angles that add up to 180, that's wrong. It's got to be two angles that add up to 180. And what's the definition of a linear pair? I think that was one of them on the other one.
What they get the same thing.
Two angles that have an adjacent, that share an adjacent, or that share red line, because all the lines.
Yeah, sort of.
Wait, that's a linear.
Number
pair.
20, that's the actual definition of a linear pair on the very back for the word search. A pair of adjacent angles whose non-common sides are opposite rays. That's the definition. I wouldn't really want you to write that down. What I want you to remember about a linear pair, two angles that together make a what? A line. That would be good enough for me. All right? Two angles that together make a line. All right, on the word search. Questions on it?
Could you just go down and tell us what each words are? Like,
I don't want to go through all that.
you just have to say one is this, two is this.
I gotta read it all and go through all
No,
that.
you don't.
Yeah, I
It's
do,
not
because
five.
I don't have a key. So I'd have to read it and,
Oh, I think out loud. I was like, I hate when people do that. We can read.
We'll read them, you answer them.
no, it's gonna take too long. Ask me questions.
What's one?
What's
I
four?
was just kidding.
I don't know. Hypothesis.
Which one you looking at?
Four.
4. An educated guess based on known information. This I would not put on there because a lot of you think it's hypothesis because of science class.
Conclusion.
And that's not it. It's not a conclusion. It's a conjecture.
Oh.
Conjecture.
Yeah.
So in here,
Oh,
conjecture
it's right there. Oh.
is an educated guess based on known information, and conjecture is right here towards the middle.
I just started highlighting the words that were in this class that we used.
Yeah, I didn't actually.
I saw.
Gotta make sure you got 20 of them
Yeah.
because I'm collecting them and grading.
Well, I don't have all of them.
I think I
did
had
5
18.
more.
Next one.
About 7.
If a statement is represented by P and then not P, then not P is the negation of the statement.
So, conjecture, maybe?
No.
What is it? Negation?
Negative.
I think it is negation.
What's number?
I don't know why they put the word in
Oh,
the,
yeah, that is negation.
What's number 10?
where is negation at in here?
It's right here.
It's right
It's like right in the middle to the left.
across, up,
Oh,
right
right
here.
here. All right, negation.
What's number 10?
Number 10, basic undefined term of geometry. Remember back at the start of the year? Back at the start of the year, we talked about 3 terms that won't be on this vocabulary test because I told you those 3 terms didn't have what?
Wait, what?
Talked about 3 terms at the start of the year, very first section of the book. 3 terms that don't have what?
Undefined terms.
Right, so they don't have what?
A point.
They don't have a definition. And what were those 3 terms? Point, line, and plane. So am I gonna put these on this vocabulary test? No, it'd be sort of stupid to put something on there that doesn't have a definition. Now, which one actually fits number 10? Says, a blank is a flat surface made up of points that has no depth and extends indefinitely in all directions. Plane. Plane's a flat surface that extends in all directions forever and ever. Again, plane is,
Where's
Found it.
congruent? Is number 14 conditional or whatever?
yep,
Where's that at? And then conditional.
it's at the very top
Oh,
line.
I have it. Dang it! I can't find the words I'm missing.
1 or 2 more real quick.
9.
Number 9, a statement that describes a fundamental relationship between the basic terms of geometry. That's not the definition I gave you, all right? The definition I gave you is this, and this is an important one. A mathematical statement that we take for granted is true.
Your
A
postulate.
postulate. Number 9 is postulate.
So that.
Look at number 8. Number 8 is a mathematical statement that has to be proven true. What's that? Theorem.
Wait, is postulate on here?
What?
I don't see it.
So postulate is,
Yeah,
Postulate, it's like, have you found counterexample?
Yeah.
You could eat.
Oh my gosh, I quit.
What's number?
Postulate's right here.
I have it.
What?
What's number 16?
Who did I have all the words?
16, angle blank, a ray that divides an angle into two congruent angles. This one's probably important also.
where's theorems?
It's like the.
I'm not gonna find, oh, I have to, silly me, I knew that.
An angle blank is something that splits this angle into
Angle bisector.
two congruent angles. That would be a bisector. Again, that one is important. You need to know an angle bisector is a ray that divides an angle into two congruent angles. Bisector is,
It goes to a midpoint and it's like right next to, it's like underneath the E.
it's like diagonal there, isn't it?
It's a diagonal.
It's diagonal right here.
I have it, probably have it.
What is it?
I don't even see a B. Okay, I see now.
I'm convinced I have all the words.
Hey,
My
my
ones I
problem
don't
is
have,
that
I have.
Cute and funny.
What?
I just need to know where it's cute and funny.
I was able to find out like what the words were, but I couldn't find them in it.
Where's the postulate?
1, 2, 3, 4, 5. Wait, what's 20? Would that be like,
Cute is right here.
I'm really
I
bad at
found it.
words.
She told me.
One more question. You need to have, make sure your names are on this and have a clean sheet of paper out.
Where's postulate on here?
it's in between supplementary and
It's right in the middle. Is that it? All right, make sure your names are on them, put them on the blue chair, get out a clean sheet of paper.
What are two non-adjacent angles formed by intersecting? Would that be vertical?
Yep.
And then a pair of adjacent angles whose non-common sides are opposite rays.
I have word, I quit.
Hey!
So I go for it and I turn it and later.
Make sure your names are on them, put them up there on the chair. Whether they're finished or not, turn them in, other than Ruth, because she wasn't here.
What's a pair of adjacent angles whose non-common sides are opposite rays?
I'll give you 3 minutes. You have 3 minutes to ask me questions about vocabulary stuff. If you ask me a dumb question or a silly question, anything that I deem to be stupid.
We're starting.
Yes, there are stupid questions.
Then we're starting the test.
Then we're starting the test. So, my first class said, the first question out of their mouth was, all right, give me a vocabulary term that you want me to define, and somebody said, all of them. We started the test.
Oh, I have a question. I don't know if this is dumb, but I'm just gonna take a risk. Do we have to like determine, like, say what any of the postulates are or theorems?
You need to know what a postulate and a theorem is probably, but not actually give a postulate or a theorem.
Okay, so,
Give me a term. Postulate, you want that?
Yes.
yeah. and-
Postulate's a mathematical statement that we take for granted is true.
What's the thing on?
Theorem is a mathematical statement that must be proven true.
Okay.
I feel like this
Just take a risk.
Well, I don't know what
If it's a term that we've had, then it's not gonna be
It's
stupid.
not a term, it was just a question about the test. Like, it wasn't about the terms. But like, is there a bunch of terms on here that we're gonna have to do, or is it like 10?
Yeah, somewhere around there. Usually I won't make these real long.
Do we do this like every 3 minutes or whatever?
Yeah, we're gonna do it quite often. Probably a couple times a week, sometimes 3 times a week, depending on how many times I have you in.
Are these words just as
But that means
much
it'll
for
be
other
short.
tests?
They'll be like 4 words.
Yeah, they count
That
as a
means we'll
test
have a
grade,
test
yeah,
every day
just about.
that week.
These are shortened, so Chloe, they don't count quite as much because there's not as many points on this as,
Yeah, but the more you miss, the worse your grade is.
that's true.
Midpoint.
Midpoint. Midpoint is a point that splits a segment into 2 congruent segments. point that splits a segment into two congruent segments. Good, that's a good one. Give me some others. We got about a minute left. Start naming, going through stuff that we've done in here.
Conjecture.
And I'll tell you if it, I'll tell you the definition, then I'll even tell you if it's an important one or not. Conjecture. For a conjecture, I want you to write down is statement. That's another name for it. Probably wouldn't put conjecture on there.
Do we have to know what like I think it's conjunction or whatever, and
Conjunction.
dis.
Conjunction uses the word, is a compound statement that uses the word and. Disjunction is a compound statement that uses the word or.
Do we have to know the symbols on this?
Probably not, no. Probably wouldn't put that on there.
Converse, inverse, and contrapuntal.
Well, wait.
Probably wouldn't put those on there. If I did put those on there, I just want you to tell me that the converse does what? Switches the hypothesis and the
So
conclusion.
theorems are statements that have to be proven true. Postulates are ones that we what
Take for granted.
Take for granted.
We assume
That are true.
Other questions?
Wait, what's just say midpoint again?
Midpoint's a point that splits a segment into two congruent segments. Just same as the one we just got done doing, only what was the one we just got done doing that's sort of like midpoint? Angle bisector. Angle bisector is a what?
It's two angles into two.
Splits an
It's
angle.
a ray
into
that
two-
splits.
Ray
How
that splits an
specific?
angle into two congruent angles.
How specific do you have to be? Like we forget a word.
I
Like say
mean,
we forget ray, we just say
there's-
like a line.
There's key things. I mean, if I was going to do complementary angles, all right,
You say just angles, not two angles.
then that part would be marked wrong. So
Well,
complementary angles, things I look for, and complementary angles would be two angles, add up to 90. Those are two key ideas.
Yeah. What would a ray be?
Array, I probably wouldn't put that on there. Array is sort of like a line, a point.
Yeah, I was gonna say what you
Uh,
say.
It's not the one that wanted to
And,
line for us.
and as a matter of fact, you noticed on the thing, they said a point on a line and all the points out in one direction. They sort of explained it to you. That's array.
I would have said a line that stops on one side and keeps going on the other. That would have been wrong.
Yes, yes.
It's not a line.
All right, put everything away except for a clean sheet of paper. Nothing else should be on your desk. When you get finished, you lay it on the blue chair. I'll have the other papers off of there. Also on the other blue chair are your tests. When you bring your vocab test up there, grab the other test and sit quietly until everybody gets finished. I'll give you about 12 minutes or so to do this. Shouldn't take any longer than that. Go over your other test and we will answer questions over it after the vocab test. Begin. Make sure you write clearly enough that I can see what everything is. Don't smash everything together or anything. Don't leave it up to me to decide whether it was right or wrong. On the vocab, we'll go over these real quickly.
I know I missed probably.
Midpoint. What's a midpoint?
A point that divides a segment into two segments.
All right, point that splits. Might be real important to listen. I'm telling you, we're going to take a bunch of these, and if I put them on here the first time, do you think they're going to be important the second time, the third time, the fourth time? Yeah. Point that splits a segment into two congruent segments. Perpendicular. What's perpendicular?
I
Lines
put,
that form four right angles.
okay,
Lines that
Intersect to form right angles.
intersect. This is the actual definition. I'll probably accept anything close to that. Intersect to form right angles.
What if you said to form four right angles?
That'll work.
Okay.
mine said two lines that intersect to form four right.
That'll work. Theorem.
I was
It's a two.
Something
What's
that-
the theorem?
Statement that must be proven true.
A statement that is proven true.
Math statement
Proven.
True.
That can be proven true.
that must be proven true. Vertical angles. This is the only one of any of them that we do. Vertical angles is the only one that I accept a drawing on. So if you didn't know the definition, and that goes for whatever vocab test we take from here on out. Vertical angles, the actual definition of vertical angles is two non-adjacent.
Why should I do with
I
that?
put two angles that don't share a side but share a vertex.
I said they have a
Two
common
non-adjacent
variance.
angles section.
Two non-adjacent, listen. Two non-adjacent angles formed by two intersecting lines. Now that's the definition. I really don't care that you remember that definition. So if you put something like this comes up again and you put it on there. Maybe you put like angle 1 and angle 2 there and you say angle 1 and angle 2 are vertical angles. I would probably accept that. Next one. Congruent. Same measure. That's the easiest thing to put, same measure. If you put have, save it, have, or having the same measure, that would be fine also. Angle bisector.
A line that.
A ray that
that's-
splits through an angle into two congruent angles.
Ray
Ray.
that splits
Cause the line goes, I said line.
an angle into two congruent angles. Angle, or a ray that splits an angle into two congruent angles. Collinear, what's collinear?
On the same line.
And you should,
Two or more
Points on the same line.
you should put this, you should put points, I probably won't mark it wrong this time, but what's the only thing that can fall on a line? Points.
I put two or more.
I said
So
put
points
something
on the same line. Points on the same line.
What do you put? Two or more points on the same.
That's fine.
I said when something-
Postulate, what's a postulate?
That's
The
the same
statement
thing
that
with
we
the
have,
math
statement that we take for granted.
All right, math statement,
I put that as taken to be true.
that is taken to be true. So math statement that's taken to be true. Supplementary angles.
Two angles that angle 180
Two
down.
angles whose sum equal 1.
Two angles that add up to
180.
180.
Is mine not good enough?
Two angles that add to 180 degrees. Linear pair, what's a linear pair?
Two adjacent supplements.
Now what, we just went over this
I
one.
put
Two angles
I
that are
put-
adjacent and they're non-common size are opposite rays.
Alright, so that's the actual definition, right? And I told you an easier definition before the test, what was it? Two angles that together make a line, alright? Two angles that together make a line. That's a little easier than the one that Kelsey said, right? Kelsey said the actual definition, what the book says. That's a little easier.
Mine is
Just
like-
picture
mine
memory
is
that I
like
knew, so I just wrote it down. I
Two
was like,
lines.
And that's the exact, I mean, that's the right definition. Mine's probably not quite right. You don't want me to take that away from you, do you? So then stop it. That's probably not, this definition's probably not exactly right, but yeah, I wouldn't hand it to her because she will get
It's
taken away.
mine.
Oh, well then she might want to put it away.
It's my baby.
So put it away.
Called a
I
trash
was
can.
about to, it fell off the street. Oh my god.
Probably don't wanna, it's not something you wanna do right now. Alright, on your test, on the actual chapter 2 test. Questions, problems you wanna see worked off of the chapter 2 test. You'll have to read it to me. Make sure that the tests get put into your binder where they belong.
Okay, I want whatever
21.
Yeah, 21. Because I got
Majorly
confused.
Somebody read me the given.
WX equals YZ.
What are we trying to prove?
WY equals XZ.
Alex, her.
So give you that string.
I can't read lips.
Which one of you am I gonna know?
She was trying to ask me a question. I'm so confused. You can repeat. Me? What? I'm the problem. I might as well leave. Can you see back there?
Or just today?
We'll see how you start acting.
Just today.
I wouldn't count on that.
It's just today.
I wouldn't count on that.
I'm sorry. No. I learned.
And they gave us a picture. Looks something like this. Somebody tell me the letters. What was this letter?
W,
This one?
X,
This one?
Y.
So the given information tells us that WX is congruent to YZ. That's all the given information. Now we gotta come up with stuff on our own. What's something else that we look at this? I told you if you just had a picture like that, you were probably gonna use what? Told you this, that you're gonna do this for the entire year. If you have a picture that looks like that, you're probably gonna use what postulate? Segment addition postulate, good. Well, we're actually, even with this, we're gonna use segment addition postulate somewhere through here. If I tell somebody to walk from W to X, and then I tell somebody else to walk from Y or from Z to Y, what do you know about the distances they walked? They're congruent, they're the same. Now, if I tell this person that's standing on X to walk to Y, and I tell the person that's standing on Y to walk to X, what do we know about the total distances that they've walked? They're the same, all right? And the way we figure that out is this distance and this distance together are the same as this distance and that distance together, because all I had the two people do is walk that XY, which was the same for both. So what do we know about this whole distance and this whole distance? They're gonna end up being equal to each other, all right? And that's what the two-column proof is trying to say, right? Now, I don't know if I'll write this out exactly the same as theirs or not, because I'm not looking at the paper. What's the first thing I'm gonna write down?
Given.
WX equals
YZ.
YZ. How'd I know that?
It's given.
It's given to us. Now, the next thing, I had the two people that were standing on these walk, and then I had both of them walk what segment?
XY.
XY. Well, when one of them walked X, Y, and the other one walked X, Y, what did we know about those two distances? They're the same, they're equal. What property tells us that?
Reflexive.
Reflexive property. Good.
I got more rams on your test.
Reflexive property.
But then I realized it was reflexive.
Remember, reflexive property says anything equals itself.
That's the only
Anything
thing I remember.
equals itself. Number 3,
WX plus XY equals XY plus YZ.
I'm still learning. Oh my god.
you really don't want to go any farther today. So you might relax, Olivia. So we know that. XY equals XY reflexive property. So that's equal to itself. Now the next part that they say, I think they said something like this. WX plus XY equals YZ plus XY. What did they do to go from here to that?
Nothing? Oh, so plus
They added,
addition, property of equality.
they added XY on both sides. Well, if you add the same thing to both sides, what is that? Say it again.
Addition, property of equality.
Addition, property of equality.
And this is where it all went downhill.
So we added the same thing to both sides, and we know that this distance, first person walk that I was talking about, is the same as that distance. Then after that, that's where we got to put in, okay, this person walked from here to there, then they walked from here to there, well, then they walked that total distance right there, and that's what we're gonna write down here. WX plus XY equals, what's the total distance?
WY.
WY. And then the other person walked YZ plus XY, which what's the total distance for
XZ.
XZ? Anytime you see something that looks like this segment plus this segment equals the whole thing, what are you using? Segment addition postulate. Segment addition postulate. Number 5.
WY equals XZ.
Look at what we have and so that you can understand, because it's not just knowing how to write this down, you gotta understand why you're doing these things. Well, if you look right here, that same thing is right there. Look there, that same thing is there. Well, if these two are equal to each other, what's that tell us about these two on the second parts of each one of those? They have to be equal, they have to be congruent, right? In this case, it's WY equals XZ. What property did I use when I took these equal things out and stuck these two in their place? Substitution property. Substitution property.
I have no idea how I got that right. I mean, it's right, but I don't know how I knew that.
I got the second call.
Never did good on
things
things.
right, and I was so proud of myself.
Next question.
14, because that's the only one that I missed, and it's the only one that I wanted.
Read it to me, please.
All integers are real number, and half is a real number.
Just half is an integer. Which one is that? What did you put? I put an integer.
All integers are real numbers.
Yeah, I missed that one too.
So that's our first statement. Then it says 1/2 is a what?
Is a real number.
Is a real number. Now I actually changed this, and you could probably tell in the test I changed this because the book actually put something in there like 5 or something. It said 5 is a real number. All right. Now, the reason I changed it, and I'll explain that here in a minute. 1/2 is a real number. Okay. But remember, when we're doing this, we're going from here to here And then we gotta make our own conjecture. We gotta come up with whatever we're gonna say. This tells us that if it's an integer, then you know for sure it's a what? Real number. What's this next statement tell us about?
Real number.
Real number. Can we jump backwards and say then that that's an integer?
No.
No, it doesn't work that way, does it? So we can't make any conclusion here, so what we write on this one is no conclusion.
Oh,
Now, what if they would have said 1/2 is an integer? Then could we have said something about 1/2? Then yeah, it would have had to been a real number. But you can't go backwards. You can't say, using the law of detachment, we said integer tells us real number. You can't start with real number and then say, okay, that tells us integer. It's got to go in the same order. So on that one, no conclusion. Other questions? No? Make sure those get into your binders where they belong. Today is the 20th. Go ahead and start copying this down. Today we do want to write this down. We are going to get to that. So put your blanks, put your leave a little space for 2 or 3 sentences at the end of class. Remember, I know a lot of you forget about it, that when we do these little short reflections and I go around and check them, they count as a quiz at the end of the 9 weeks. You don't see the quiz on your grade card or on your Moodle because I wait till the end of 9 weeks and then I put it in there and then you never see it. But at the end of 9 weeks, it does count as something. Also, with the break coming up, binders will be due probably not long after we come back from break. So make sure you're keeping them caught up, keeping them in line. Because usually around this time, it ends up getting sort of everything crammed together.
I haven't got my OGT quiz back and I turned it in like 2 weeks ago. Where's Katie?
what test? She took it. Liz taking a test.
Okay, so do teachers have to have grades in by like a certain time for stuff?
Supposed to update your grades every week.
I'm waiting for my test grade from Mr.
Because
Bryant for like,
I got a
for like
Yeah.
literally like 3 weeks.
Literally. We took it last month.
Wait, what?
Like,
No,
we took it
like
we
the
were
first week in
interns
November.
so it was
First week in November.
Yeah.
For
social studies?
No, for biology.
Was it something that you didn't take it late or anything?
Yeah, I didn't even know that. Well,
So
I
Maybe you
with
should just,
everybody
you,
else?
you think
I
you might get the
wondered
hint that his
because-
tests are too long, it takes him this long, it takes him 3 weeks to grade them, they shouldn't be this long.
He's
like,
Because
on
I
Tuesday,
have
he was like,
a 45
I'll be honest
in
with you,
Spanish.
I didn't do anything to your
Because
test over the
Mr.
weekend, like,
Curry
thanks.
still has a 0 in for my grades
great.
that I've already turned in. He still has his.
Be able to identify special pairs of angles. We've talked about special pairs of angles all year long. Name me one special pair of angles that you already know.
True.
Vertical angles,
Adjacent.
adjacent angles. there's another one on the test.
Complementary.
Complementary, supplementary, all those are special pairs of angles. Today, we're gonna talk about special pairs of angles that are formed when you have coplanar lines and a transversal. Coplanar lines and a transversal.
This is a new unit, right?
Yep.
Is this hard? Harder than last one?
I don't know that's, it's different than the last one. I don't know that's harder, can't really say. Is it gonna be, it depends on the person. Looking at these, you probably already, with this sort of bluish line here and the red line, they look to be what to each other? Parallel. And we're gonna talk about that later on in the chapter. When you have, first of all these lines are coplanar to each other because do they all fall in the same plane?
Yes.
Yeah. So when you have coplanar lines, and then you have a line that looks like this one here. So we're looking at these two parallel lines here, or two lines that look like they're parallel. We don't want to say they're parallel because we don't know that for sure. But we're looking at these two coplanar lines, and you have this. That line is your transversal, and all a transversal is, and we're going to talk about this on the next slide, or next couple of slides. Transversal is any line that intersects two other coplanar lines. So it intersects both those other two coplanar lines. So other than that one, what's another line that's a transversal for the blue one and the red line?
The green one.
The green one. So this one right here would also be a transversal. How about this maroon one out here?
No.
No.
Yes.
Why yes?
This line's going.
Line's going forever. So this line's gonna continue on up there. Is it gonna intersect those two lines somewhere up there in space? Yeah. So that would be a transversal also. And we're gonna talk more about that. Just know I'm gonna go over this very, very quickly. We're not gonna actually use this today. I'm not sure, I can't remember why I put this slide on here, but apparently I put it on there for some reason. These two arrows here, those two arrows, tell you that these two lines are parallel to each other. If we're writing something out, then this is the symbol for parallel. We're going to talk more about that after break. So that's why I'm skipping over that real quickly. All right, write this down. We'll do these definitions here in a second. Planes are named with three non-collinear. What's non-collinear mean again?
They're
Not on the same line, points on that plane. Earlier this year, when we were naming a plane, remember a plane might look something like that? They gave you some cursive letter in one of the corners and you named it plane P or plane F or plane T or whatever. And a lot of times those cursive letters were, I never could figure out because they like to use F and T and I couldn't figure out which one was an F, which one was a T. So this is another way to name a plane. If you're given points that fall on that plane, just like with lines, rays, and all that other stuff, we had ways to name them. If you're given points that fall on that plane, you pick three non-collinear points, and you can name the plane that way. So this one could be named plane, I don't know, EAD. Give me another way to name that plane. DBC. Plane, there is no symbol, so you just have to write out the word DBC. Are there several other ways to name it? Yeah. All right, so any three non-collinear points, remember, three non-collinear points, how many planes are there going to be that contain those 3 points? One. That was one of the postulates that we had. Parallel lines. Or I'm sorry, parallel planes. I read it wrong. Parallel planes are two planes that what?
For parallel?
Yeah, you don't want to use the word in the definition.
Side by side.
Never intersect. Two planes that never intersect.
Clever. Whoever said that. Clever.
Two planes that never intersect. Name me two parallel planes in the room.
Go. The floor and
That
the ceiling.
The floor and the ceiling.
The two ends of the.
All right? This wall, that wall, the what?
Two ends of the board.
Two ends of the board. Be careful now, we want planes.
No.
Those would be
That
down
one.
here, right? Those two walls, probably the ones that I'll use more than any others. If we're dealing with parallel planes, ceiling and the floor, because those are probably the easiest two. We're gonna skip down to parallel lines. What are parallel lines? And listen, because I'm not gonna yell at you. I'm not gonna make fun of you when you give me the wrong answer, but you are gonna give me the wrong answer.
'Cause you're so
All right.
good.
So what are parallel lines?
Two lines that never intersect, and that's wrong, isn't it?
That's wrong. All right? The reason it's wrong. That's what your teachers taught you in the past, but the reason they taught you that is because they couldn't teach you everything. And we're going to learn more about it today. I got these two lines. Does that describe what Ariel just described to me?
No,
Two lines that never intersect?
no, because they will intersect.
They will?
No.
Not if I could hold them straight.
I was thinking of like,
They're never going to intersect, are they? Are they parallel to each other?
No.
All right?
Two
You need
lines
another word in there,
that
don't
must
you?
be parallel and
What other
never-
word?
Oh, I just can't use the word.
Sorta. What's that? Give me a geometrical word.
so what?
Opposite.
Two,
Oops. Let's get rid of that.
two.
What has to be true about these two lines? What's not true about this?
They have to be straight.
All lines are straight.
They have to be.
Two lines
They have
that
to
are
be equal to each other.
no, not
Yeah.
Lines can't be
Really?
congruent, can they?
Well, no, not like that. Like they have to be facing the same exact way.
So,
But two,
not adjacent.
vertical.
two.
I'll give it to you.
Horizontal.
What's this little thing say up here?
Congruent. Co-planar.
They have to be in the what?
I don't know.
They have to be in the same plane. If they're not in the same plane, like these, is there some plane that would contain both of those?
No.
No, there's no flat surface that would ever contain both of those. These are not coplanar lines. So to be parallel, it's two coplanar lines that what?
Never intersect.
That never intersect.
You know, that's weird. Like, we get up here in high school and they're like, alright, say this definition. You're wrong. Your teacher taught you wrong.
Well, they didn't teach you wrong, just laid on my pink chair.
It was cold
They-
in there.
They just told us what you
Okay.
needed to know back then. You didn't even talk about planes back then, right? So you didn't need to know about planes. Well, now you need to know that if I have these two lines, they have to be in the same plane. Otherwise, they could be lines like this, and they're not parallel to each other because they aren't in the same plane. Okay? Let's jump back to this one. What do you think skew lines are?
Two lines that never intersect.
All right, now we got to be careful here because we need another word in there. Two
Non-coplanar.
non-coplanar lines that never intersect. Two non-coplanar lines that never intersect.
Do we have to have the OGT practice thing in our notes?
Yeah, no, in your test and quizzes section. So these two lines would be parallel to each other. These would be skew lines. These lines, parallel lines, we're going to deal with a lot. Skew lines, not as much. All right, not hardly at all. Because can they show you skew lines? They can sort of show it to you in the book, but can they really show you skew lines in the book? No, because if I draw two lines up here, if I draw a line here and a line here, you're going to think that they're on the same plane, not skew lines, right? It's because the way that they look like they're going to come together. A transversal. Transversal is a line that, sorry, start using cursive, intersects two coplanar lines. That's all a transversal is. A line that intersects two coplanar lines. I'm going to draw a little picture over here just to sort of show a transversal. If I can draw it without hitting the stupid buttons at the bottom. The blue line here, that's your transversal. So, line that intersects two coplanar lines. So you got parallel planes, skew lines, parallel lines, transversal. The stuff that we do today, we're not going to go into the parallel lines and all that a whole lot. This is what we're going to go into more, just learning these special pairs of angles. I'm going to flip the light off so that you can see that a little better.
There's our freckles.
Yep,
So we write all this?
yep,
You know, to draw that picture.
yeah, otherwise you wouldn't see what angles are.
We have to draw that picture.
Yeah. These last four down here, those are your special pairs of angles. Those are the ones that you're going to have to pick out in a diagram. The first two, just exterior angles and interior angles. If we're looking at this, you have your two coplanar lines. This line right here is called the what again? We just said it.
Transversal.
Transversal, thank you. That's the transversal. For exterior angles fall on the outside. So they're outside the two lines. Those are your exterior angles. Guess what the ones in the middle are called? Interior angles. Real difficult. These in here, I just circled red. Those are your interior angles. So if we're talking about alternate interior angles, then you know both angles have to fall where? On the inside, interior. We're talking about alternate exterior angles, then both angles have to fall on the outside. So when you're looking at these names, don't make them harder than they are. One thing you might want to jot in here, consecutive interior angles. I'll probably mess up at some point and call them same side interior angles. So sometimes I'll mess up and say same side interior angles, because I taught out of other books, and that's what they called them in the other books. In this book, they call them consecutive interior angles. Same thing, just two different ways to name the same thing. As you're writing these down too, notice math people very, very creative. Consecutive interior angles, alternate exterior angles. I'm being sarcastic. All the names tell you is where the angles are located. What's consecutive mean?
Constant.
One right after the other, right? What's alternate mean?
One, skips one, I don't know.
Right, it like jumps, right? And that's the same thing in these names.
Are you already switching to the next slide?
Oh, good, I thought you were switching. I'm not done.
No, it's just erasing one up on it.
I'm just gonna copy Teresa's intervention, because I don't like the minutes order.
No.
Save.
on the assignment today, all you're gonna actually do is they're gonna want you to pick out these angles. This pair of angles is what special pair? This pair of angles is what special pair? Consecutive interior angles. If we're looking on the interior here, we want angles that are consecutive, or again, sometimes I call them same side. Well, you could probably guess what angle looks like it's on the same side as angle 3.
4. 5.
Because 3, to get to 4, you'd have to jump over that, right? So 5's on the same side. It's there in that same sort of house there, all right? So 3 and 5 are consecutive interior angles. 4 and 6 are consecutive interior angles. Alternate exterior angles. First of all, to be alternate exterior angles, they both have to be exterior. So if I picked angle 1 out here, what angle do you think would go with angle 1 to be an alternate exterior pair? Angle 8, because it's like opposite corner, right? Alternate. So then 2 goes with what? 7.
So 3 would
So
go with
would
6 and
angle
7.
Now be careful because we're not there yet. Oh, that's the next one.
Angle 1 and angle 8 be vertical angles.
Now, are they vertical to each other? Because do they share the same vertex? 1 and what are vertical angles?
4.
1 and 4 are vertical angles. Okay? And now, do we forget all that other stuff that we've learned? What do you know about 1 and 4?
They're congruent.
They're congruent. What do we know about 1 and 2?
Adjacent.
They're adjacent. They add up to 180. They're supplementary. They're linear paired. All that stuff. So don't forget all those other things that we learned. Alternate interior angles. Alternate interior angles. Remember, they got to be interior angles. So 3 here. That's angle 3. Which one alternates with it? Which one's on like the opposite corner? 6. Now look what happens if I trace angle, lay it on my chair up here if you would. If I trace angle 3 and I trace angle 6.
Forms a Z.
Forms like a Z or an N or a lightning bolt or whatever you want to call it. Alright? Every time you trace a pair of alternate interior angles, and that's going to be an important pair of angles that we're going to use quite often, it's going to form a Z or an N, or depends on how the picture looks to begin with. Alright? Corresponding angles. Easiest way to describe corresponding angles. If I have my 2 coplanar lines and I smash it together, not fold it over, just smash them together. Alright, so that they're laying one over top of the other. Corresponding angles are going to lay one over top of the other. And that's why there's more of these, and this one's sort of important too. So if I smash these 2 together, 7's going to lay over top of which angle? 3. Does everybody see that?
No.
So if I took them, I smashed them together. Not fold them, don't fold it, just crunched it. 7 is going to come down here,
3.
lay it right on top of 3. 5 is going to lay on top of
So like.
1, 8 on top of 4, and 6 on top of 2. Those are all corresponding angles. Notice there's more of those. That's why they're important, because you can make them a whole lot more because there's more of them. So those special pairs of angles, that's what the assignment's going to deal a lot with. All right, that's your assignment. Page 128. And the whole thing is just picking out those special pairs of angles. Looking at a picture and picking out a pair of corresponding angles, a pair of alternate exterior angles, pair of, I keep wanting to say same side interior, pair of consecutive interior angles, so on, so on, so on.
like can't read.
Pre-test at we're going to do that. Like pre-test, like facility, surface area, kangaroos. I'll get a pass to come down and work with you.
So I moved you, look, so I moved you, so that you wouldn't get in more trouble. That's what I'm trying to explain to her, but apparently.
I tried to find it freshman sophomore year, it didn't happen.
So Olivia, either relax. Alright. I have this bad feeling that you don't. Sydney, you're not gonna turn that paper into me?
What?
You're not gonna,
It's not done, but,
better than zero.
Huh?
Right, better than zero, isn't it? Lucky I even said anything. It'd be easier for me to write just a zero in there. Here, I give you a compliment the other day, saying how well you're doing, and then you're gonna
I
backslide. on
grabbed it last minute, like I finished my test last minute, and
You still had 2 days to do it. What's that got?
too late.
Grabbing it last, what's that?
I didn't realize it was homework. I didn't even do it until last night.
I told you it was homework. It said on the board it was homework.
And then,
After I took my test, I
Sydney,
felt
you're
pretty
having
confident
this
about the
argument and
test.
it's not gonna help you.
I know.
After I took my test, I felt pretty confident about it.
I felt
And now
very
I'm really
confident
happy about
my
it,
test
because
and
I only missed one question.
You did really well.
felt very confident about my test until I seen what I got on it.
You heard some of those other people sitting in here, they didn't do quite as well as
I
they
got a 71.
Sharice was in here and she was like, and Kelsey over there with missing only one question.
I got a 71 on it. I'm pretty proud because it was very easy, but one I did not understand.
See stuff like this? Do the assignments and it'll make it easier on you.
I second guessed myself on that question that I missed on the test.
So you had it right at first?
Yeah, I did.
just picking out pairs of angles here. If we wanted to pick out just certain pairs, alternate interior, alternate exterior, corresponding, consecutive interior. Whenever you have a picture that has 4 lines in it instead of just 3, what you gotta do is make sure you pick out the 2 lines that you wanna deal with and the 1 transversal that you wanna deal with. So I'm going to put some letters on these lines. Oops, I skipped one, doesn't matter really. So we got those, C, D, so that we can, so we got line A, line C, line B, line D. Doesn't matter what the lines are named. Remember, we can name these lines with lowercase letters at the ends of lines instead of the 2 letters that we normally name a line with, you know, something like line QR or something like that. That I would rather you name them with the 2 letters, but sometimes it's just a little more efficient, a little easier to name them this way. So if I pick, let's do lines A and C. If those are my 2 coplanar lines, then B could be a transversal or D could be a transversal, but I don't want to look at them both at the same time. So if I pick A and C and I sort of split off A and C, have something like that, and it doesn't have to be a great drawing, and I pick B as a transversal, then I have like angle 1, 2, 3, 4, 5, and 6 up here. And then you could go through and name special angles from those, like angle 1 and angle 5 are alternate exterior angles. And I will abbreviate a bunch on this. Angle 2 and angle 6. It's this angle and this angle. Well, if we trace those, we talked about that in class, then they form a Z. Those are alternate interior angles. If we look at angle 2 and angle 3, it's this angle and this angle. They're both interior angles and they're on the both on the same side of the transversal, so we call those consecutive interior angles. And if we look at angle 1 and angle 3, well, if we smash this line down over top of this line, angle 3 would lay over top of angle 1, so those are our last pair that we talked about, and those are corresponding angles. And that's all you're doing right now, you're just picking out the special pairs. Now let's say you wanted to use line B and line D as your 2 coplanar lines. Then use line B and line D, and you could either use A as a transversal or C as a transversal. If I pick C, so if I drew in C up here, then you'd have 3, 4, 5, 6, 7, 8, 9, 10, and then you could go about picking special pairs of angles from that, like 5 and 7 here are consecutive interior angles. Angles 9 and 5 are alternate interior angles. Angle 3 and angle 8 are alternate exterior angles. Angle 4 and angle 7 are corresponding angles. Then you also need to remember, don't forget about all the stuff that we've learned up till now. Stuff like angle 10 and angle 7 there are a special pair of angles. They are vertical angles, so you know stuff about them. Angle 3 and angle 6 together form a line, so they're a linear pair or they're supplementary angles. So you still know all that stuff. Again, your assignment, page 128, 4 through 17, 22 through 48, the even numbers, 49 through 51.